Hello, Matt Davis here with more homework quiz help. This one comes from section 9.3. In-N-Out Burger is a very popular fast food restaurant on the West Coast. In fact, it's so popular that during peak times, the drive-through lines can become 20 to 30 cars long. A stat student wants to see if, during those peak times, the average drive-through wait time is greater than 10 minutes. He collects a random sample of 12 cars during the peak time and finds the average wait time to be 11.72 minutes. With a standard deviation of 4.5922 minutes. Calculate the p-value for the test stat and round your answer to 4 decimal places. So we're being asked about the p-value here, so we are going to do that. But to get the p-value, you need to get your test statistic, and you also need to know what your claims look like. So we're actually going to work on steps 1, 3, and 4, and then we'll throw in step 5 just for good measure. So even though I'm working on this specific problem from active learning, the work here should help you with the problems that come before and after as well. So let's jump in and start writing down the null and alternative. But first, let's go ahead and make some changes so we're giving help, not answers. So instead of this 11.72 right here, I'm going to change that to 11.74. All right, now let's jump in. So for step 1, you want to write down your null and alternative hypotheses, and the key thing that you need to do first there is always figure out, are you in mean land or proportion land? And in this problem, we're doing a study about the average drive-through wait times. So it's about an average, so we're in mean land. So HO will state that mu equals something, and H1 will be a claim about mu also. So what is it that we're trying to show? We're trying to show that the wait time is greater than 10 minutes. That sounds like H1. So HO always has to have the same number, so that would be equal to 10 minutes. Alpha is not given here, but step 2 is where we normally write that down. You need alpha to be able to do step 5, so we'll have to talk about the fact that it's missing when we get there. But let's go ahead and keep going because you don't need alpha for step 3 or 4. So step 3 is to calculate the test stat. So what that looks like, it depends on whether you're in mean land or proportion land. And we said right here that we're doing a claim that mu equals 10. So we're in mean land. In mean land, we calculate t-scores. And the formula from the formula sheet for those is x bar minus the claimed mean mu 0 divided by the sample standard deviation divided by the square root of the sample size. Let's start trying to find those pieces. So for the x bar, that's our sample mean. It says that he collects a random sample. So this is everything that comes after is about a sample. So that 12, for example, is the sample size. The mean came from that sample, so that's x bar. The standard deviation came from that sample, so that's s. So there we have x bar, s, and n. The only piece that's still missing is mu 0, but mu 0 is the value that comes from h0, so that's that 10 right there. All right, so let's plug all those values in. So doing so, we get t equals x bar, 11.74, minus the claimed mean of 10, divided by the sample standard deviation s, which is 4.5922, divided by the square root of the sample size, which was 12. And then we can go to the calculator and see what we get. So let's do that and see our value for t. So a key thing on the calculator, you need parentheses around the top. So that's going to be 11.74 minus the claimed mean of 10 divided by, now when you go to the denominator, you need both of those numbers in the denominator. So to make sure that happens, you put parentheses around them. So open parenthesis, 4.5922 divided by the square root of 12. The first end parenthesis is for the square root. The second end parenthesis is for the denominator. Press enter. Round our test statistic to 3 decimal places. That would be 1.313, rounding that 2 up because of the 5 that follows it. All right, let's take that number back over and write it down. So our test statistic we came up with was 1.313. And I believe that's what they're asking us for. Note they want the p-value on this one. So this is the answer to the question before for the test stat. So that's a key piece right there. But now let's take that and continue on and do the p-value. So for the p-value, we want to draw a bell-shaped curve. And this particular bell-shaped curve will be a t-curve because we are working with a t-score. In the middle, we'll put the 0 representing the claimed mean of 10. And then our test statistic is positive, so that'll get shown on the right-hand side. And then when you decide whether you're going to shade to the left or the right, that has nothing to do with whether your t-score is negative or positive. It's all about what H1 says. And H1 has a greater than, so we're going to shade to the right and do a greater than like that. And then for a right-tailed test, if that area to the right is our p-value, then we can label that like this. Find that using TCDF. And let me go ahead and carry that down here. So let's see. Yes, the p-value is that value, but let's have some more space. So the p-value is equal to TCDF. Left-hand boundary is right here, 1.313. Right-hand boundary, we're going forever to the right to infinity. And the number of degrees of freedom is important. This is a t-curve. The df is n minus 1. Since n was 12, the df will be 11. So we'll put that in there. And let's go to the calculator and get that value. So distribution menu, TCDF, left boundary was our t-score, 1.313. Right boundary was infinity, so alpha I, where we have infinity stored, and then the number of degrees of freedom, which was n minus 1, so 11. This is our p-value, so we round it to 4 decimal places, so that'll be 0.1080, rounding that 79 up to an 80 or 80 because of the 5 that follows it. P-value is approximately 0.1080. And then for step 5, because the p-value is 0.1080, that would be greater than any of the standard alphas, which are 1%, 5%, and 10%. And if our p-value is greater than alpha, that would imply we would reach the conclusion of do not reject HO. Again, whether we reject or does not reject does depend on how the p-value compares to alpha, and they did not give us alpha here. So I'm making the assumption that we have a standard alpha of 1, 5, or 10%, in which case our p-value would be greater. Some places to watch out for mistakes. When you're doing your test stat in the calculator, make sure you put parentheses around the top and the bottom. The bottom is the one that people forget more often, so be careful, extra careful with that. Make sure you're using TCDF instead of normal CDF because you do have a t-score. And when you're doing a t-score and TCDF, you need a degree of freedom. Don't double here because we're just doing a right-tailed test, not a two-tailed test. And then make sure that you get your boundaries in the correct order. That's usually easier for people when they're positive. Make sure you use that infinity on the right-hand side. Hopefully somewhere in there you caught the stuff that was giving you trouble. Good luck to you as you head back to the quiz.